Hello, I'm Dr. John Kruse, and today I'm going to be talking about the glymphatic system, which is the waste disposal system of the brain, and how that might be important for ADHD. I'll be talking for probably less than 20 minutes, and I've gotten some feedback that I should give my takeaway in one simple sentence or so first, so people who have short attention spans and don't want to listen for 20 minutes don't have to, so I'll get to that in a moment. If you have questions while I'm writing this or I'm speaking this, certainly you can sign in and I will try to get to questions at the end. This will be posted both on YouTube and Facebook, so if you have questions later, I can answer those there too. So the takeaway is that we have a system in the brain called the glymphatic system, which is a system for washing away the junk in the brain and also important for fluid balance within the brain. That system operates primarily at nighttime and primarily during sleep at nighttime. And this may be a particularly important reason why regular nighttime sleep is important in ADHD to prevent damaging garbage from building up in your brain. So that's the takeaway. So a little bit more background information. The lymphatic system in our body is one of the bodily systems that laymen pay least attention to. It's sort of a weird hybrid system that's part circulatory system, part immune system. And the lymph system, again, this is in the body, not in the brain, is composed of lymph itself, which is that clear fluid, primarily blood plasma, but also cellular debris, different proteins, bacteria, and special cells called lymphocytes. So you've probably heard of both T cells and B cells. We've been talking about them as fighting infection and COVID and other disease processes. They're called lymph cells because they are fundamental parts of the lymph system. The lymphatic system also consists of small lymphatic capillaries and small, slightly bigger lymphatic vessels, and those drain into two bigger lymphatic ducts in our torso, and eventually those lymphatic ducts dump into the venous system and go back to the heart. So primarily, or a big role of the lymphatic system is to manage what we call interstitial fluid. So interstitial, this adjective, the interstices are the spaces between the cells. So we have a circulatory system, which is largely a closed system for heart pumping through the arteries, through the capillaries, out to the body, coming back to the venous system. That's a closed system. The lymphatic system is sort of the leakier system where the fluid that's seeping and sitting between all the cells in the body seeps into the lymphatic system and then again gets recycled by dumping into the venous system, into the heart. And then again, some of the leakage from cells from our vascular system leaks out. The other organs of the lymphatic system are sort of things that the organs that nobody really understands. I mean, medically we understand what they do, but the common knowledge is, what does your spleen do? What does your thymus do? What are your tonsils for? Those are all elements of our lymphatic system, as are the lymph nodes. And most of us are most familiar sort of medically with lymph nodes as what your doctor's palpating for when you're coming in with an infection. So the lymph nodes are drainage sites, filter sites, where the lymph system, the lymph fluid is filtering through the node, and if there's infectious agents, that's where the immune part of the system enlists more cells to fight off and attack whatever may be foreign or undesirable in the body. And when the lymph node is swollen, that means more immune cells have jumped in there or proliferated within that site to fight off infection or to treat some other condition. So we're aware of lymph nodes at that time. And again, part of this is sort of a less simplistic system maybe than the heart or the lungs. Just part of it's why we pay less attention to it. And also because it's less centrally connected to many illnesses. If you have a heart attack, you drop dead. If you have asthma, that's clearly impacting breathing. So there are a few diseases specifically of the lymphatic system. One is elephantiasis, which is an infectious disease, but it causes blockage of the lymphatic system. And again, fluid flow, particularly the interstitial fluid, is part of what the lymphatic system regulates. With elephantiasis, people's legs and sometimes other body parts grow to grotesque dimensions because the body is not effectively getting rid of, removing that interstitial cellular fluid. And the other areas, disease-wise, we're familiar with the lymphatic system. One is lymphoma, which is cancer of lymph cells. And the other big area is because a primary mode of metastases with different forms of cancer is through the lymphatic system, which is why when they do, if you have breast cancer and they may or may not remove the breast depending on size of tumor, extent of tumor, but they're also going for lymph nodes because, again, the malignant cells collect together in the reseed the lymph cells, which are filtering out the lymph system. So those are, how the body deals with getting rid of a lot of its garbage. So for years, decades, centuries, the lymphatic system in the body was fairly well known, but nobody could identify a lymphatic system within the brain. Now, within the brain, what do we have? We have a ventricular system. So we have these cisterns or sort of pools within the brain of cerebrospinal fluid. We have two lateral ventricles, and there's 4 ventricles altogether that drain into a central medial ventricle and the 4th ventricle and out of the body. So the lymphatic system, though, can't deal, it's too far away from most of the cells in the brain to be effectively dealing with flushing out elements from the brain. So again, that's a fairly closed system. In the interior of the brain, there's also cerebrospinal fluid bathing the surface of the brain, but all those cells buried in the midst of the body of the brain, which we call the parenchyma of the brain, certainly couldn't get rid of their waste through that system. So around 2013, research, and primarily by someone at my alma mater, the University of Rochester, so a Danish neuroscientist, and her name is Maiken Nedergaard, and hopefully I didn't butcher it too much. In her lab, she has several collaborators and researchers describe what they call the glymphatic system. So glia, coming from the word for glue, are the non-neurons of the brain, and for years, even though the glia have outnumbered the other brain cells by about 10 to 1, so we have about 10 times as many glial cells as neurons in the brain, they've been largely sort of ignored by neuroscientists because they didn't do the important stuff of sending to cell-cell communication and controlling how we sense the world, how we process, how we think, how we act, how we behave. But clearly the glia are important, and the glial cells are, particularly one set of glial cells called astrocytes, are an important part of this brain's lymphatic system, this glymphatic system. So in the brain, it's cerebrospinal fluid is made by certain cells lining the brain. That fluid bathes or seeps into the parenchyma of the body of the brain, bathing the different cells within the brain, and some of the waste from those cells, both waste expelled from in the cells and waste that accumulates external to the cells, the interstitial space of the brain, as it were, then congregate or gather in this paravascular. So para is along the blood vessels of the brain. So it isn't a part of the vascular system of the brain, it's a paravascular system. And these little lymphatic systems then flow together, and then eventually, and this was discovered or sort of confirmed a year after that 2013 finding of the glymphatic system, in the brain there actually, even though they looked for years and were not clearly able to find it with more modern cell markers and electron microscopy, there is a lymphatic system in the brain, well actually particularly the meninges, which are the lining, the tough membrane is the dura mater, and the pia mater is the flimsier membrane or lining covering the outside of the brain. So there we have genuine cells like the lymphatic system has throughout the rest of the body. So the lymphatic system within the brain does feed into this meningeal lymphatic system, and that material is flushed out of the body and into the general circulation back to the heart and can be recycled. Important pieces of the glymphatic system in the brain. There are special channels on the astrocytes, water channels called aquaporin number 4 particularly, which again in the body, lymphatics are important for regulating the interstitial fluids, likewise in the brain. And these astrocyte pores, the aquaporin number 4 water channels, help water get into the system at 3 or 4 times more efficiently than simple diffusion would be. How substances move through the system, because again, we're not dealing with a heart pumping like this, is that actually the pulsations from arteries within the brain seem to be part of what's propelling fluid through this system. And the exciting findings of Nedergaard's lab and confirmed by others is that in mammals and evidence so far as including humans, that this system is far more active during sleep and virtually quiescent during daytime. And in fact, the studies indicate that there is actually sort of increase in that interstitial space brought about by sort of shrinkage or contraction of nerve cells themselves to create more space, more flow, more ability to flush things out. That happens specifically not just during sleep, but recent studies published just at the end of last year by Nedergaard's lab showed that there is a circadian rhythm to this, so that if you put someone in an anesthetic-induced sleep, for 24 hours, and this was done in rodents, not in humans, but the lymphatic system is working actively not just throughout all of sleep, but particularly during times that the animal would be sleeping. So there's both a circadian clock factor going on and the activity of sleep itself. And Nedergaard's group and others are thinking that for years, and I have some other talks on sleep here, for years we've not really known why sleep is so important. Why would you put animals in such a vulnerable position if it were just to give them rest or just some of the other things that have been thought to be important for sleep? But if flushing out garbage and dangerous accumulated cell toxins is important enough, then that may be a reason that we segregate a certain, in humans, about a third of our life to this sleep function. So tying this all back to ADHD, so some of the research already actively going, and this is all at very preliminary stages, so some of this is more speculative than confirmed, is that, we know that for some of the big brain disease, and it's going to be increasingly problematic, dementias, Alzheimer's and other dementias, their characteristic features are accumulations of debris within the cells, so neurofibrillary tangles within the brain cells, and beta amyloid plaques in the extracellular space around nerve cells. These are both different sets of proteins that accumulate in normal, healthy brains, are flushing this away, but in brains that develop Alzheimer's, and there is not a perfect correlation between these protein-based brain garbage accumulations and dementia, but there's a close correlation. So if you are free of all these deposits, you almost certainly don't have Alzheimer's going on. There are certainly some people who show some significant buildup of either beta amyloid plaques or tau, neurofibrillary tangles, who don't have dementia, but there's a strong correlation both in terms of amount and location of these protein deposits. And the Alzheimer's drug that was approved, whether it should have or not, we may talk about later, aducanumab, which is specifically designed to get rid of, break down, and help flush away and prevent the accumulation of beta amyloid plaque. So there's evidence that not just in dementia, but some other brain pathological conditions are due to failure, either producing extra junk and that's overwhelming the system, or maybe the garbage system, this lymphatic system, isn't working well enough. In certain people, there's also growing evidence that just having damage in the brain, either from strokes or maybe even from concussions, can damage this lymphatic system and make it less efficient, effective in flushing out proteins. And again, the concern with ADHD, given that so many people with ADHD have disruptions of sleep, that if you are not getting sufficient sleep, again, not just the duration, not just having 7-8 hours at night, or 7-8 hours, but getting it at the specific circadian time that your lymphatic system is trying to flush out garbage, your sleep, may be restorative in terms of feeling better the next day, or being more alert, but you may be contributing to long-term damage if you're not getting good enough sufficient sleep and sleep at the right time. So that's why I'm talking about it in this connection with ADHD. I see there's at least one question I'll try to get to in a second, and then next week's talk is going to be about treating ADHD with either electrical or magnetic stimulation treatments, and that'll be next week. So the question I see here is, will meditation help with this? So one of our other talks was looking at meditation certainly brings around certain, or activates certain, so meditation isn't just shutting down your brain or turning everything off. It's not just leaving it in a default ruminative, what's called the default state of the brain. Meditation does seem to particularly activate certain calming systems of the brain. I don't know of any specific data so far linking whether meditation activates or helps invigorate the glymphatic system or not. So I don't have a direct, simple answer. Clearly, there are health benefits for meditation, even just a few minutes every day, and particularly people with ADHD, if they can train themselves to meditate, most of them feel and experience both greater relaxation and greater ability to focus during the day. So that's what I have to say for today. Stay healthy, stay happy, and I will be back next Friday at 11.